we started oxoacids of sulfur. In the type 1 we started. In type 1, I told two examples. One is H2SO3. Second one is H2S2O2. Sulfurous acid, thiosulfurous acid. The type 1 we call them as sulfurous series oxoacids. Sulfurous series oxoacids. Sulfurous acid, thiosulfurous acid. Third example, H2S2O4. This H2S2O4 is called as hyposulfurous acid. Also called dithionous acid. Hyposulfurous acid, dithionous acid. This compound contains sulfur-sulfur linkage. I told all these oxoacids of sulfur are dibasic acids. That is one advantage for practicing these oxoacids of sulfur. This H2S2O4 this is structure of hyposulfurous acid, dithionous acid. Here sulfur, 1,1 lone pair, and here both sulfurs sp3 because of lone pair. Both sulfurs pyramidal, and both sulfurs have same oxidation state, +3 and +3. Average also +3. So this is third oxoacids of sulfur in sulfurous series oxoacids. Sulfurous acid, thiosulfurous acid, hyposulfurous acid, or dithionous acid. Next, fourth example in this H2S2O5. So this is original acid H2SO3 sulfurous acid. Double the formula minus H2O. This is compound. That's right. This is called as pyroacid. Pyrosulfurous acid, also called disulfurous acid, because we are doubling the formula and we are removing H2O. It's called disulfurous acid. And this H2S2O5, my extension of H2S2O4, one more extra oxygen we have to put. And here sulfur lone pair. This sulfur sp3, this sulfur sp3, but here no lone pair. Therefore, near first sulfur, left side sulfur tetrahedral. Because of lone pair, right hand side sulfur is pyramidal sulfur. So one pyramidal sulfur and tetrahedral sulfur are linked, and oxidation states also different. Left hand side sulfur +5 oxidation state, and right hand side sulfur +3 oxidation state. In these oxoacids of sulfur, these oxidation states are important. Both sulfurs have same oxidation state, different oxidation state, individual oxidation states, average oxidation states. Here each sulfur, what is the shape? This is pyrosulfurous acid or disulfurous acid having tetrahedral as well as pyramidal sulfurs. H2S2O5. So these are the 4 examples in sulfurous series oxoacids type 1. Type 2. Sulfuric series oxoacids. Sulfuric series oxoacids. Type 1 sulfurous series. Now we have sulfuric series oxoacids. In that, the starting compound is H2SO4. A simple oxyacid, sulfuric acid, sulfur, double bond O, double bond O, OH, and OH. So sp3 sulfur, tetrahedral sulfur, sulfur plus 6 oxidation state. Next, in this we have thiosulfuric acid. Thiosulfuric acid, putting sulfur in place of oxygen. So don't disturb OH oxygen. So one double bond O you have to remove. So this one also contains SS linkage. Generally, Nana, compounds containing SS linkage are called as thio compounds. So thio linkage means SS linkage. Like azo linkage, NN linkage, SS linkage is called thio linkage. In this is sulfur -2, this is sulfur +6. Or we can write 0 also here. Terminal sulfur. If you put 0, then central sulfur +4 oxidation state. But out of these two, please highlight first pair -2 and +6. First preference -2 +6. In both cases, average no change. +2 and +2 average in both pairs of oxidation states. Thiosulfuric acid. We have an important salt also with this thiosulfuric acid. It is thiosulfate, sodium thiosulfate, called as hypo. Next we have H2S2O7. In this sulfuric series, thiosulfuric acid formula is H2S2O3. Now H2S2O7. From this, double the formula, 2 into H2SO4 and minus H2O gives H2S2O7. That's why this is called as pyrosulfuric acid or disulfuric acid. Disulfuric acid, also called oleum, also called fuming sulfuric acid. This can be represented like this also, H2SO4 and SO3. Oleum samples. Okay, in your stoichiometry important part, oleum sample, labeling of oleum sample. But in special cases we have, one is for hydrogen peroxide volume strength, and next one is sulfuric acid representation, oleum representation. This pyrosulfuric acid contains SOS linkage, sulfur oxygen sulfur linkage, H2S2O7. Dibasic acids, all oxacids of sulfur are dibasic acids, H2S2O7. In this, both sulfurs are in same oxidation state. Left hand side sulfur plus 6, right hand side sulfur also plus 6 oxidation state. These are the three important oxoacids of sulfur in type 2 sulfuric series oxoacids. Sulfuric acid, thiosulfuric acid, pyrosulfuric acid. Previously sulfurous acid, thiosulfurous acid and hyposulfurous acid. Next, type 3. In type 3 we have peroxo series. Peroxo series of oxoacids. We have two compounds now, very important compounds. First one is H2SO5. Second one is H2S2O8. This is called as peroxo monosulfuric acid. Peroxo monosulfuric acid. In the previous case, in all cases, central sulfur atom undergoes sp3 hybridization. And in central sulfur atom, tetrahedral only. No lone pair in central atom, no. That's why in these three oxoacids of sulfur, no pyramidal structure near sulfur. All sulfur central atom sulfurs are tetrahedral. In peroxo series, peroxo monosulfuric acid, and right side one peroxo disulfuric acid. Peroxo disulfuric acid. This is called Garros acid. Right side one is called Marshall's acid. And both contains peroxy linkage. One peroxy linkage. Both compounds contains one peroxy linkage. Oxygen with -1 oxidation state linkage. And this peroxo monosulfuric acid, all oxoacids of sulfur, dibasic acids. So this is peroxo acid. -1, central sulfur plus 6 oxidation state. And this H2S2O8, it contains SOOS linkage. This H2S2O8, no SS linkage, no SOS linkage. It contains SOOS linkage, sulfur, oxygen, sulfur linkage. -1 peroxy linkage, plus 6 here, here also plus 6. In this compound also, all sulfurs undergoes sp3 hybridization and no pyramidal geometry. Only tetrahedral structure we have. In peroxo series, two types we have. Peroxo monosulfuric acid and peroxo disulfuric acid. The last type in oxoacids of sulfur, thionic series. Important. In thionic series, two examples we have. The first one is basic compound H2S2O6, and second compound is H2SNO6. This second one, Nana, derived based on the catenation capacity of sulfur, H2SnO6. Here also all oxyacids of sulfur, dibasic acid. In H2S2O6, this is called as dithionic acid. Dithionic acid contains SS linkage, sulfur-sulfur linkage. Dithionic acid. Here also, near sulfur, no lone pair. Means both sulfurs undergoes sp3 hybridization. Oxidation state nana, both sulfurs plus 5 oxidation state. In this H2SnO6, putting N here. It poly SS linkages, catenation capacity linkages. But till now, they derived N value from 1 to 12 nana. But in this important examples, two examples I am writing here. One is N is equal to 1, another one is N is equal to 2. If you put N is equal to 1, we are getting 3 sulfurs. That's why it is called trithionic acid. Trithionic acid. If you put N is equal to 2, tetrathionic acid. Right side compound, very important compound, tetrathionic acid. So if you put N is equal to 1, then formula is H2S3O6. If you put N is equal to 2, H2S4O6. Trithionic acid and tetrathionic acid. And here in trithionic acid, one sulfur in the middle. Left hand, see the middle sulfur, Nana, please highlight middle sulfur. This middle sulfur has 0 oxidation state. This is very important, Nana. Generally, in the previous case, we have terminal sulfur, I put 0, but basically it is -2 sulfur. But here compulsory 0 only, because both sides sulfurs are there. It's not terminal sulfur. So therefore, left hand side sulfur is +5, right hand side +5. In this trithionic acid, average oxidation state of sulfur is +10/3 nana. This is one simple mistake we are doing. +10/2 you are writing, because not 2, it is 3 sulfurs are there, so +10/3. Now in tetrathionic acid, HOSSS, catenation capacity. Because in 6th group, sulfur has high catenation capacity. That's why it forms SS linkage compounds more effectively. Now here middle sulfurs both 0 oxidation state. Left hand side +5, right hand side +5. In this tetrathionic acid, average oxidation state of sulfur is equal to +10/4, the +2.5 average oxidation state. So these are the two important compounds, important series, thionic series oxyacids of sulfur. Basic example is dithionic acid. Next one is called polythionic acid. If you put N is equal to 1 to 12, till now they derived. And here One more point I am writing. Number of SS linkages. Number of SS sulfur linkages. So each compound we have to practice. Okay. Let us write individually. It is better to write individually. In trithionic acid or dithionic acid, SS linkage is 1. Okay. Here SS linkage 2. Here SS linkage 3 SS linkages are there. That point also important. H2SNO6 polythionic acid. Dithionic acid, and this is called polythionic series. Polythionic acid. These are the total 4 types of oxoacids of sulfur and their structural aspects. And finally, one more point I am writing here, conclusion point. I am taking H2S2OH, peroxodisulfuric acid, Marshall's acid. So HOSOOS OH, double bond O, double bond O, double bond O, double bond O. Now I am adding water. I am doing hydrolysis. Then break the bond here. Oxygen side hydrogen, other side OH. Then we are getting 2 compounds. Observe left side compound, Nana. It is Carros acid. Left side compound, that is H2SO5 plus H2SO4. If you take H2SO5, HOS double bond O, double bond O, OOH. Now another step of hydrolysis. And further hydrolysis, break the bond here. Hydrogen, other side OH. Then we are getting hydrogen peroxide plus H2SO4. So this is one method of preparing hydrogen peroxide from Marshall's acid. So 2 equations are there. What is first equation? H2S2OH first step of hydrolysis plus H2O, it gives H2SO5 plus H2SO4. Next one, H2SO5 plus H2O gives rise to H2SO4 plus H2O. If we add both reactions, we are getting complete hydrolysis of Marshall's acid. That is H2S2OH plus 2H2O gives rise to 2H2SO4 plus hydrogen peroxide. Next, one more point. Among all oxoacids of sulfur, two examples I am highlighting with SOS linkage. SOOS linkage. Only two compounds we have. One is H2S2O7, another one is H2S2O8. These two compounds also please highlight. No SS linkage. One compound SOS, another compound SOOS linkage, peroxy compound, oleum and Marshall's acid. Next, one more point. We have H2S2O3, thiosulfuric acid. It's a sodium salt. Na2S2O3, sodium thiosulfate. This sodium thiosulfate used for the volumetric estimation of iodine. Volumetric estimation of iodine. A very one of the famous reaction of sodium thiosulfate is with I2. Gives rise to Na2S4O6 plus NaI. Na2S4O6, sodium tetrathionate, sodium tetrathionate. We have two titrations, Nana. Iodometric and idimetric titrations. చాలా famous reactions we wrote to. ఒకటి ప్రాక్టీస్ చేసుకోండి. మాలిక్యులర్ వెయిట్ M అయితే ఈక్వలెంట్ వెయిట్ హౌ మచ్? ఎవరైనా చెప్తారా నాన్న? మాలిక్యులర్ వెయిట్ ఈస్ M, its equivalent weight. The sulfur oxidation state plus 2.5, sorry, plus 2. ఇక్కడ sulfur oxidation state plus 2.5. ఇది చేంజ్. ఈ ఈక్వేషన్ ప్రకారం ఈక్వలెంట్ వెయిట్ ఈజ్ ఈక్వల్ టు మాలిక్యులర్ వెయిట్ నాన్న. N factor 1. These are the important points related to oxoacids of sulfur. Next we have oxides and oxoacids of chlorine. Oxides and oxoacids of chlorine. First one I am writing oxides of chlorine. First one Cl2O, ClO2, Cl2O6, Cl2O7, plus 1, plus 4, plus 6 and plus 7 oxidation state. Dichloromonoxide, chlorine dioxide, dichlorohexoxide, dichloroheptoxide, Cl2O, yellowish brown colored gas. This one, yellowish green gas. This one, dark red liquid. This one, colorless liquid. In oxides of nitrogen, two colored compounds we have. One is NO2, red brown gas, and N2O3, blue color solid. Now here, in oxides of chlorine, three colored gases, two colored gases, and one colored liquid is there. Yellow brown gas, yellow green gas, dark red liquid, and colorless liquid. The oxides of chlorine. Next. So Cl2O, ClO2, Cl2O6, and Cl2O7. Plus 1, plus 4, plus 6, plus 7. So less. This is acidic nature of oxides. If an element from number of oxides as oxidation state increases, acidic nature of oxide also increases. Next we have oxoacids of chlorine. 4 oxoacids we have. One is HOCl, HClO2, HClO3, and HClO4. Plus 1, plus 3, plus 5, plus 7. Hypochlorous acid, chlorous acid, chloric acid, perchloric acid. Hypochlorous, chlorous, and perchloric acid. Next point. So Cl2O, ClO2, Cl2O6, Cl2O7. Corresponding oxoacids: HOCl, HClO2, HClO3, HClO4. Plus 1, plus 1. But here we have plus 4 oxidation state. That's why with water it gives 2 acids, intermediate oxidation state. Here plus 3, Here plus 5. So plus 4 means both comes out. Here plus 6 oxidation state. HClO3 and HClO4. Whereas Cl2O7 gives HClO4. That's why Cl2O and Cl2O7 are called as simple anhydrides, whereas ClO2 and Cl2O6 are considered as mixed anhydride. The two acids comes out, no? So next point. Next point. Cl2O plus H2O gives H4Cl. ClO2 plus H2O gives HClO2 plus HClO3. Next, Cl2O6 plus H2O gives HClO3 plus HClO4. Next, Cl2O7 plus H2O gives HClO4. For Cl2O is called as simple anhydride of H4Cl. Cl2O7 also simple anhydride of HClO4. ClO2 is called as mixed anhydride of HClO2 and HClO3. Cl2O6 also mixed anhydride of HClO3 and HClO4. These two reactions also disproportionation reactions. Disproportionation reactions. That's why out of these four oxides of chlorine, two oxides gives two types of salts during neutralization. That is ClO2 and Cl2O6 gives two types of salts with then strong bases. Cl2O only one type of base, Cl2O7 only one type of base comes out. So among these four, two oxides of chlorine undergoes disproportionation reaction with water as well as with alkalis. That means Cl2O plus NaOH gives NaOCl plus H2O. Like ClO2 plus NaOH. Two acids, two salts comes out. NaClO2 plus NaClO3 plus H2O. So disproportionation with NaOH. Cl2O6 plus NaOH. NaClO3 plus NaClO4 plus H2O. Next, Cl2O7 plus NaOH gives NaClO4 plus H2O. So with water disproportionation, with alkalis also disproportionation. With alkalis, two oxides gives two types of salts, and two oxides gives only one type of salt during the neutralization reactions with strong bases like NaOH. NaOCl. This is called sodium hypochlorous acid, no? Sodium hypochlorite. This is chlorous acid. So sodium chloride. This is chloric acid. Sodium chloride. This is perchloric acid called as sodium perchlorate. Salts names. Next, coming to oxo acids, HOCl, HClO2, HClO3, and HClO4. After losing proton, corresponding anions, ClO2 minus, ClO3 minus, ClO4 minus. The ClO4 minus is more resonance stabilized. That's why HClO4 strong acid, more acidic among these four acids. Therefore, HOCl less than HClO2 less than HClO3 less than HClO4. This is the order of acidic strength. For oxo acids, mainly acidic strength decided by Ka and pKa values. But in some cases, we can explain acidic strength on the basis of oxidation state. In some cases, most important point is we're explaining acidic strength on the basis of resonance stabilization of its corresponding anion after losing one proton. All are monobasic acids. So here no question of removing second electron, third electron. So HClO4 is strongly acidic among the oxo acids of chlorine because its anion is more resonance stabilized. If anion is more resonance stabilized, then corresponding acid is strong acid. Coming to these anions obtained from oxo acids of chlorine, ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. This is called hypochlorite ion. Chlorite ion. Chlorate ion. Perchlorate ion. If you observe bonding in these four anions, ClO minus. So near chlorine, only 3 lone pairs. Next to ClO2 minus. Near chlorine, 2 lone pairs. ClO3 minus. Chlorine, 1 lone pair. Next to ClO4 minus. No lone pairs. ClO minus means obviously linear, no chance of bent, like only 2 atoms are there, no? And this one is bent. This one is pyramidal. And this one is tetrahedral. In all these, we have sp3 hybridization near chlorine. In ClO2 minus, bond angle 111 degrees. In experimental values, please remember this. Bond angle 111 degrees. And here, bond angle 106 degrees. And here, bond angle 109 degrees. Second value, please highlight none. Exceptional bond order in ClO2 minus. And one more point I am explaining here. ClO2 minus chlorine 3s2 3p5 3d0 3s2 3p5 3d0, but we need 3 bonds, no? So excitation, it is first excited state. So 3s2 3p4 3d1. In this 3s2 3p4 3d1, but we need one pi bond, no? So pi bond formed by unhybridized orbital. Therefore, leave one orbital for pi bond. Generally, last orbital we are leaving. Then remaining undergoes sp3. But this one form pi bond. What type of orbital, Nana? D orbital of chlorine overlap with p orbital of oxygen. Therefore, ClO2 contains one pi bond. Now, what type of pi bond it is? D orbital of chlorine with p orbital of oxygen. And we need here first excited state, not ground state. Suppose if we take one more anion, ClO3 minus, ClO4 minus. So one more excitation, one more excitation. So for ClO3 minus, second excited state. For ClO4 minus, third excited state. But overall, if you observe, all pi bonds are d pi p pi only. No p pi p pi bonds. So that is the important point I want to write here. So next, ClO3 minus, 2 pi bonds, both d pi p pi. Here chlorine is in second excited state, sp3 only. Next we have ClO4 minus. In ClO4 minus, 3 pi bonds. All are d pi p pi. Here chlorine is in third excited state. Here also chlorine sp3. It's important point, the number of d pi p pi bonds. So ClO2 minus, ClO3 minus, ClO4 minus all contains only d pi p pi bonds. Next, one more point I am writing here. This is also important. If you take Cl2O6, solid form of Cl2O6 contains ClO2 plus ClO4 minus. This is called as chloryl perchlorate. Chloryl perchlorate. Cl2O6 plus H2O. Cl2O6 plus HF. Cl2O6 with NO2. The three reactions I am giving to support the ionic form. One is with water, one is with HF, one is with NO2. With H2O, it gives HClO2. Sorry, HCl. 1 minute. HClO2 plus HClO4 with HF, ClO2F plus HClO4 with NO2. NO2 is odd electron molecule. So ClO2 plus ClO4 minus. NO2 is odd electron molecule. That electron is given to ClO2 plus. Then it becomes ClO2 neutral molecule. And NO2 becomes NO2 plus. That NO2 plus form salt with ClO4 minus. We are getting NO2 plus ClO4 minus. This is called as nitrile or nitronium perchlorate or nitrile perchlorate. The important name is nitronium perchlorate. NO2 plus is called nitronium ion. So nitronium perchlorate, also called nitrile perchlorate. These reactions, all these three reactions, supports the ionic form of Cl2O6 as ClO2 plus and ClO4 minus. Now here it is ClO2 plus F minus, H plus ClO4 minus, H plus ClO2 minus, so ClO2 plus. 1 minute. ఇక్కడ మనకి చిన్న ఇక్కడ ఒక నిమిషం Cl2O6 కదా మనకు వచ్చేది HClO3 వస్తుంది అంటే +6 కాబట్టి ఇంటర్మీడియట్ +5 +7 ఈ HClO3 HO.ClO2 ఇలా రాదు అంటే ఇప్పుడు HO మైనస్ ClO2 ప్లస్ ఇక్కడ H ప్లస్ ClO4 minus. These reactions supports ionic form of Cl2O6 as ClO2 plus and ClO4 minus. ClO2 plus OH minus. Chloryl hydroxide. Chloryl hydroxide. ClO2F. Chloryl fluoride. NO2 plus ClO4 minus. Nitrile perchlorate or nitronium perchlorate. This NO2 is odd electron molecule and supplies oxygen electron to ClO2 plus, and it becomes NO2 plus. NO2 plus forms salt with ClO4 minus. Nitronium perchlorate salt. The few points about the oxides and oxyacids of chlorine. Remaining tomorrow will continue.
Cl2O6 what do we call, sir?
ఏమన్నా
Cl2O6 కి మనం ఇందాక లేదో అన్నాం కదా
ఏంటి
అంటే Cl2 ప్లస్ Cl4 మైనస్ అయోనిక్ మిక్చర్ అన్నాం కదా సార్.
అవునవును
Cl2O7 కూడా అవుతుందేమో సార్.
అవ్వదు
అవుదా సార్?
అవ్వదమ్మా ఇది ఒకటే
అంటే దాంట్లో కూడా Cl3 ప్లస్ Cl4 మైనస్ అలా వస్తుంది కదా అని నేను అనుకున్నాను సార్.
లేదు ఒకటే ఉంది.
ఓకే సార్.
Tomorrow will continue remaining.
Thank you, sir.